we learned there are different types of progressions. We were talking about the one of the progressions from sequence. We said sequence is any kind of numbers arranged in a pattern. That's a sequence. And then we said that if a sequence is following a rule, that will be called a progression. And then we talked about a unique progression which is called arithmetic progression. Arithmetic progression had a rule that if you subtract the current term from the previous term and go on like this, you will find that the common difference would be same, or the difference of these terms, two subsequent terms would be same, and that is what was an AP, and we called that arithmetic progression. We looked at some of the examples of arithmetic progression. We solved some examples as well. We talked about something in detail regarding AP. We said that AP is a sequence of the form A, comma A plus D, comma A plus 2D, and A plus 3D, and so on and so forth. So the last term of the AP is A plus n minus 1 into D, and this is what we call as nth term. Nth term of the AP is A plus n minus 1 into D, where A is your first term, D is your common difference, and n is your number of terms. Sometimes another term is also called the last term of the AP. The last term is basically again A plus n minus 1 into D, wherein n is your number of terms in the series or the sequence, sorry. Now, going forward, we'll try to understand or rather figure out whether the following series is an AP or not. 1, 1, 1. It is also an AP, by the way, wherein your common difference is 0. Yeah. So this is also an AP. So D could be 0, positive, and negative. So as we mentioned, so I didn't ask you, but say if I had a series like this, 1, 0, minus 1, minus 2, minus 3, minus 4. This would also be an AP, whereas your common difference is actually minus 1. So we learnt about something called nth term of the AP. Now what we will learn here is sum of an AP. Here. So let's say your AP is something like this: A plus D, A plus 2D, and it is going on and on. And your last term is basically A plus n minus 1 into D. So if I have to figure out what is the common difference over here, what will be the common difference? Common difference is D. Then what is my first term? First term is also A here. Now, what I want, what I'm interested in here is that I want to know the summation of this particular progression. So, so let's take an example so that it is easier. Then we will come to the notation form of summation. So, say I have a progression like this: 1, 2, 3, 4, 5. So, what I want to do is I want to find the summation of this uh, AP, and when once I do that, basically it will be this. I'll denote the summation by a symbol S, and what I'm interested in is to find out 1A plus 2 plus 3 plus 4 plus 5. And when I'm doing it, I will also put a subscript here which is 5. What S5 denotes here is that given this progression, I'm interested in finding the sum of the first 5 terms of the series. So first 5 term of the progression. So what is S5 here? S5 is the sum of first 5 terms of the AP. So S5 is this. So I've just written all. I will get here is that 2 plus 1, 3, 3, 6, 4, 10 plus 5, 15. Similarly, if I'm interested in finding summation of first 4 terms, I will be writing 1 plus 2 plus 3 plus 4, and the summation here will be 4 plus 3 plus 2 plus 1, which will be 10. Now, Similarly, going like this, S3 would be 1 plus 2 plus 3, summation of first three terms. Okay, so I'll get here 3 to 5 and plus 1 6. S4, sorry, S2 would be 1 plus 2, which will be 3, and S1 would be, again, this is what I want you to see here. S1 is the sum of first one term. So one term or whatever. So I'll just write 1 over here. So S1 would be 1. What I'm showing you. Say if I do S2 minus S1. If I'm doing S2 minus S1, in a way what I'm doing, I'm just doing 3 minus 1. And what I'll get over here is 2. So what is 2 here? Minus S1 is giving you the second term somehow. I'm just writing T2. So a second term or A2, anything you can write. S3 minus S2 if I'm doing, what I'm getting 6 minus 3, which is again 3, and I'm getting, this is nothing but A3 itself. S4 minus S3 if I do, I'll get S4 minus S3, 10 minus 6, and I'll get 4, which is nothing but A4, and S5 minus S4 will give me what? S5 minus S4 will give me 15 minus 10, which will be 5, which is nothing but A5. So, if somehow you have been given sum up to second terms, it means that it is a summation of first and a second term. If you've been given some summation of first term itself, that is in turn S1 is nothing but first term itself. S2 minus S1, basically sum up to second term minus first term will give you second term. S3 sum up to third term, basically 1 plus 2 plus 3. When you subtract 1 plus 2, what you are left with is S3. So sum up to third term, sum up to second term. When you subtract, you will get third term itself. Sum up to fourth term, subtract sum up to third term, you will get the fourth term. Sum up to fifth term, subtract, you will get the fifth term. So in general, I can write sum up to n terms minus sum up to n minus 1 term. What I'll get is basically an. So sometimes if they've just given you the summation up to n terms and they have given you summation up to n minus 1 term, I'll be able to find the an as well. The notation I will try to map it here because we are trying to derive a formula here. So now say this is your AP. So my S1, as I said, nothing but sum up to first term, which will be A. Now if I have to do S2, S2 is nothing but A plus D, which is going to be equal to 2A plus D. We will try to put it in some format, which we'll see later. Now I'll come to S3. S3 will be A plus, basically A plus D plus A plus 2D, and which will be something like 3A plus 3D. And now again the fourth one, and I'll stop here with this A plus D plus A plus 2D plus A plus 3D, and that would be actually equal to 4A plus 3 to 5 166D. Now I'm trying to put it in a format, and we'll see that whether it is working or not. So I'll write it like this: 2 by 2 into 2A plus, so n minus 1, 2 minus 1 into d. Okay, I've written like this. Here I'll write 3 by 2, 2A plus 3 minus 1 into d. This one I'll write 4 by 2, 2A plus 4 minus 1 into d. So as you can see, if I'm trying to solve it, I can just uh, remove 2 by 2 and it will be 2A plus d. Here, if I'm multiplying 3 by 2 into 2A, I'll get 3A, and this is 2 again, so I'll get 3A plus 3D. When I'm solving this, I'll get 2 by 4 by 2 is 2, 2 plus 2 into 2 is 4A, and then this is 3 here, so 2 into 3 is 60. So in general, what you would be seeing here is that if I'm going to write Sn, I can simply write Sn is equals to n by 2 into 2a plus n minus 1 into d. So as you can see here, what I have done here for S2 is I have put 2 by 2 because n is 2 over here. For S3, what I've done, I put 3 by 2 because n is 3 over there. And then here it is 3 minus 1 into d. Similarly, it is n minus 1 into 2. Here it is 2 minus 1 into d. Here it is 4 minus 1 into d. Here it's 4 by 2. And this 2a is 2a is 2a here and 2a here. So in general, if you have to find a summation of an AP, the formula for summation of an AP up to n terms is n by 2 into 2a plus n minus 1 into d. So we just had we calculated the summation of 1, 2, 3, 4, 5 earlier. Now we will put this in this equation and see whether we are getting that back here. So we wanted to calculate S5. So S5 is 5 by 2, 2a. A is 1 over here, and n is 5 minus 1, and d is actually 1 here. So now as you can see here, it is 5 by 2. This will become 2, and this will become 5 minus 1 will be 4. 4 into 1. So this will become 5 by 2, and 2 plus 4 will become 6, and this will become 5 into 3, which will be 15. 15 is what we did calculate when we were calculating it one by one. So 15 is what we got. Similarly, if we want to calculate, say, for example, S2 in a way, I want to calculate S2, I could just, so S2 is basically summation of this and this. So again, using the formula here, so 2 by 2, because n is 2 here, and then this will become 2 into a is 1 plus 2 minus 1 into 1, which will be 2 cancels out. So 2 plus 1, which will be 3, which I can as well see here, 1 plus 2 is 3. So this is the formula. So what is the formula here? Sum of n terms of the AP is n by 2 into 2a plus n minus 1 into d. Okay. So this is Sn, right? And we were writing our, this was a plus d, a plus 2d up to a plus n minus 1, a plus n minus 1 into d. So they we are supposed to find the summation of all that, right? So one is I'm writing a into a plus d plus a plus 2d plus a plus 3d, and so on and so forth, and so until the last one, it will be a plus n minus 1 into d. Now what they are writing, they are writing again, putting Sn again, and they are saying that the same thing, let's reverse it, like first put the last term first. So basically you can put a plus n minus 1 into d over here. This is the last term they're putting. Then they're saying that, okay, second last term. So second last term will be a plus n minus 2 into d. So third last term will be a plus n minus 3 into d, and so on and so forth. And so last here and the end here, it will be a, because I've just reversed it. So this term I put here, second term I put here, third term I put here, and all that. So they just reversed it. We'll show you by the example also. So what they're trying to do over here is that they're saying that, okay, both the things are same, so now let's sum it up. So this will become 2Sn, and now the first term will be summed up with the first term here. So while they, what will happen here is that a plus n minus 1 into d. This is 1. Now sum this with this. So what you will get here is that a plus d plus a plus n minus 2 into d. Now let's sum the third term, so which will be a plus 2d plus a plus n minus 3 into d. And then keep on going, and the last term will be this. This will be a plus n minus 1 into d, and then plus a. Now what you will see here is that this is 2Sn, and here what will happen here, this is a plus a will become 2a, and then inside this will become n minus 1 into d, the first term. The second term also, a and a will become 2a, and then when you sum up, this is n minus 2 into d, and then there's 1 d over here, so this will also become n minus 1 into d. Then the third one, this is A and A, this will become 2A. And when you sum up n minus 3 plus 2, it will again become n minus 1 into D. And when you come to the last term, as you can see here, this is already 2A plus n minus 1 into D. So this is again 2Sn. And here what has happened here, there is 1, 2, 3, and so on. Basically, there are n such terms. So everything is same. So I can just simply write n into 2A plus n minus 1 into D, because summing up these terms n times is more like multiplying it by n and then putting it like this. So now Sn will become n by 2 into 2A plus n minus 1 into D. So this is what how they have derived it. If you have not understood, let's do this in a simpler manner. For example, this is S5, and what I have here is 1, 2, 3, 4, 5. So what the modus operandi here is that they are writing it like this: 1 plus 2 plus 3 plus 4 plus 5. And same as 5, they are trying to write it like first 5 is here, then 4 is written over here, then 3 is written here, then 2 is written over here, and then 1. So they have just reversed it. Now what they are doing this 2 times as well. Basically, they are summing it up. So now this 5 plus 1 becomes 6. This 4 plus 2 becomes 6. This 3 plus 3 becomes 6. This 4 plus 2 becomes 6. This 5 plus 1 becomes 6. So this can be written as 5 times 6, because there are 5 times. So S5 is nothing but 5 into 6 by 2, which will be nothing but 5 into 3 is, which is 50. So this is the way they are doing it over here. They just reversed the AP and then sum up all the terms. What you got is the same term every time. So you multiplied it by n because there are n terms in this AP, and then you got the formula again, which is Sn equals to n by 2 into 2A plus n minus 1 into D. If I'm summing up, 1 plus 5 6, 2 plus 4 6, 3 plus 4 6, 4 plus 2 6, 5 plus 1 6. So how many times I had to write 6? 1, 2, 3, 4, 5. 5 times. Why? Because there are only 5 terms in the AP. Similarly, over here, I had n terms in this AP. So n times, I will write n times to A plus n minus 1 into D, because this term is repeating. This term is repeating n times. This is first time, this is second time, this is third time, and this is nth time. This is repeating. So that is why I've just multiplied it with n and then put n into 2A plus n minus 1 into D. So again, I'm going to write Sn. So Sn is going to be n by 2, because 2 is coming to this side, and this will become 2A plus n minus 1 into D. So this is what it is. Formula can be also written in another way, which is n by 2. And say if I am writing this as A, 2A I have split A into two parts, A plus n minus 1 into D. So 2A I have just split into two parts. Now as you can see here, this is n by 2, and this is basically A, and this is nothing but A plus n minus D is basically last term. So A plus L you can as well write. So you can also write n by 2 into first term plus last term. So as for the example which we just had, like 1, 2, 3, 4, 5, I can just find the sum by n by 2. N by 2 is basically n is 5 here. So 5 by 2. First term is 1, last term is 5. So 1 plus 5 is 6. So 5 into 6 by 2 again. As you can see, this is 15. So this is also another form of writing. This is n by 2 into first term plus last term. Alright, okay, let's see if we can do the exercise now. So find the sum of the following AP: 2, 7, 12 up to 10 terms. Can you find the sum? So what they are asking here is, there is an AP given which is like 2, 7, 12, and it is going up to 10 terms. So they are asking you to find S10. S10 is equals to what? So how will you find it? So a summation of 10 terms is directly given here, right? It's Sn is basically this, right? So Sn is nothing but n by 2 into a plus l, or a n by 2 into 2a plus n minus 1 into d. So what's your formula here? Your formula here is S10 or Sn is n by 2 into 2a plus n minus 1 into d. Okay, n is number of terms, so n is 10. What is a here? A is
Okay.
first, and then this is gonna be 2 into first term is 2 into 2 plus n minus 1 into d. N is 10 minus 1 into d is 5. So what I've got here is 2, 5. Then I will get 4 here. Then I'll get 45 here. Then I'll get 45 plus 4, 49. 5 into 49, which will be 245.